Hey, Algebra 1, let's go ahead and get into a new section, section 11.3. We're going to tackle 11.3a first. What I want you to do is, as we're looking at the book right here in section 11.3, sorry, I'm looking at my iPad. I guess I have it up on the screen as well. Um, as you're looking at this, I want you guys to see the title, first of all, Shapes of Distribution. Somehow in section 11.3, we're going to be talking about shapes, obviously, right? But also distribution. So distributions, if you were to distribute something, if you were still on campus and you were, say, distributing flyers, you'd be handing them out, right? Distributing candy bars to your class or like cupcakes for a birthday or something. Distributing means like giving them or portioning them out in certain quantities. Now, when we're talking about distributions of data, it's some sort of way of organizing, some sort of way of showing the spread, showing where the data occurs, how much of it occurs here or there. And I have to keep on saying something like data because there's so many different examples of things that we can be measuring. And you guys are going to see just a few of them today. But I want you to be looking at this page. And first of all, just think about how is the data being presented? It's not being presented in some long list. It's not being presented in like the polls or the history books where some of this is talking about some different data collected in Scotland in the mid 1800s. Like it's not talking about where this information came from. It's taken all this information from some other source and it's put it into, well, would you guys call these bar graphs? What's in common with all of these different bar graphs for right now until we have a better name is each of them show one thing's in common, and it's what's kind of measuring the y-axis. If you were thinking the x and y axis, this isn't technically like a graph, like an algebra graph, but it is a graph, just not one with an x and y axis. But you can kind of think of it as the y being the up and down. All three of them have frequency. Now, we have different things measuring the bottom axes, height and chest size when they're talking about like men in the militia, the different sizes of the Scottish men, etc. But different things mark the bottom or the x distribution or the x-axis, but the top are all frequencies. So there's a special type of bar graph that deals with frequency. Now, frequency, some of you guys maybe have heard of frequency in the sense of like, think like radio waves or think different waves if you're on a certain frequency, if you're on the same frequency as someone else. There are different ways of talking about frequency, but when we're talking about how frequent something is, remember how often or think how often it occurs? That's kind of more the meaning of frequency in this type of problem when we're talking about these types of examples. So frequency, how often something occurs or how much something occurs, keep that in mind. But we have these special bar graphs, but I want you guys to look on this page and see, okay, well, how else is information shown? Information is shown with bar graphs. Yes, you can see that here. There's a special name coming for these bar graphs that have this frequency idea over here. But don't you also see charts? Don't you also see tables? If I was to go ahead and skip really fast to your homework pages, for instance, and if we were to look at these, and if I was to ask you, okay, how do you see information being given? Do you guys continue to see those special bar graphs? For instance, over here about summer camp and a fundraiser. But that's not the only way we see data. Don't you also see these tables? Now, there is this little thing right here that's a little bit different that's not really a table or a bar graph. Well, maybe it is. Maybe it's just written in a different way. That's going to be a little unique, a little different. But the rest of homework are all these tables or these bar graphs. And so we need to basically take this lesson right now to think about who are these? What are these tables? What are they showing us? What are these bar graphs? What are they showing us? And how do we, today's main objective is who are the tables? Who are the bar graphs? And then what are their key characteristics and what can they tell us? So we're going to go ahead and before we get back into the book, let's go ahead and name these things, okay? So the first term that we're going to talk about is the histogram. The histogram is basically a special bar graph. You guys saw a lot of bar graphs. A special bar graph measuring the frequency of data. Not even measuring, maybe that's an incorrect word that I should use. Maybe a better word would be showing or displaying. So showing the frequency of data. And so right now, when I highlighted all of those frequency words, I was like, look, it's showing frequency, frequency, frequency. That is, or those all were these histogram guys. So the special name for those special bar graphs where they have frequency is a histogram. Now you can see down below, there were also tables, right? And so now we have tables. Well, what kind of tables? Maybe this should just flow right into each other because they're going to be literally frequency tables. Once again, they're tables. I mean, that's obvious. It's called a table. That also show, just in a different way, right? Show how often particular, and we could make it even a little more specific, particular ranges of data occur. But if you think about it, isn't frequency a very similar idea to how often? So frequency table, histograms, those are the two ways that we're going to see information besides that one really weird example where we had that stem and leaf plot thing. But otherwise, everything else is going to be either a histogram or a frequency table, or maybe we're making a histogram from a frequency table. As you guys look at these now, let's call it by the proper word, histograms, right? As you're looking at these histograms, you see that there are three different shapes to them. Now, that doesn't specifically say shapes here, but that's exactly what I'm going to write because this is demonstrating for us the different shapes of the histograms. So all of these are histograms, all three of them. They're those special bar graphs. They haven't even labeled what this is measuring as far as the vertical and the horizontal measurements, but that's because they're trying to keep it general and vague and say, well, it can be measuring all sorts of different things. But what is going to be the same on all of them is that they're all measuring the how often something occurs for how many times, otherwise known as the frequency. Now, I want you guys to think what we talked about in section 11.2 when we talked about the shapes of box and whisker plots, okay? Because box and whisker plots could be skewed left or symmetric or skewed right. And I want you to think about what I was talking when I was saying, okay, skewed left, that had something to do with the longest whisker, right? Skewed right had to do something with the longest whisker being on the right, whereas skewed left, longest whisker being on the left. If you guys remember that idea, I also used a karate chop or a karate kick in order to try to illustrate that. And one of those karate kicks where you kick to the side and your whole body leans the other way. And the reason why I'm using that illustration is hopefully that helps you in these ones as well. If I was looking at this data, let me get my laser pointer out. If I was looking at this data right here, and if I was thinking of, okay, if this was to illustrate a karate kick and one of those kicks to the side, do you guys see how, I know it's not exactly a box and whisker, but do you see how all of the data is leaning this way? And so if all the data is leaning this way, if the heavy side is this way, then where would that skewing be? It's very similar to the box and whisker plot. If the heavy side of the data is over here, which way am I kicking? I'm kicking left. So skewed left, I'm going to go ahead and get a colored pen just to try to illustrate that. Think about if you were kicking, you'd be kicking this direction, and that direction is left. Over here, looking at the heavy side of the data, right? The heavy side of the data for skewed left was on the right. And then for this guy, the heavy amount or the larger amounts of data is this way. But which way are you kicking? Remember, that's kind of the similar idea. Which way are you kicking? You're kicking to the right, hence why it's skewed right. And then if you notice, symmetric in a box and whisker plot was try to draw a line down the middle, and what's on one side is on the other side. And that pretty much works for this one. Hence why we call it symmetric. Now, it does say down here approximately. So as long as it's approximately a mirror image, what's on one side is on the other side, we can still call it that symmetric. But for these other guys, skewed left or skewed right, a couple things they might try to trick you on is, even though it's skewed right, even though you're kicking to the right, remember the heaviness or most of the data is on the other side or the left, like how your body leans, most of your body is this way when you're kicking out. And then similarly with skewed left, most of the data will be on the right, which might seem a little weird in your head unless you're thinking about like, oh, that's right. The heaviness or the majority of the data is this way as you're kicking the other way. Okay, so Even though it's a little bit different, even though it's a little bit new with histograms, it's still kind of similar to those box and whisker plots as far as the shapes. One big key idea in section 11.3, at least right here in part A, is number one, the shapes of these histograms, including where most of the data is depending on the skew. But then the second big idea is what's right here. And that's pretty much it. There are really just two big ideas besides the vocab words of histograms and frequency tables. Then we have that, those are the vocab words. Then we have the shapes of the histograms, or the shapes of the data, being skewed left, skewed right, or symmetric. And once we know exactly what the shapes are, it's really important to know the shape. If we have symmetric or if we have skewed, and skewed could be right or left, either one. I'll write it here just in case that helps, right or left. Depending on whether it's symmetric or whether it's skewed, right or left, there are different appropriate measures that we should use. And that seems kind of confusing, that seems kind of weird. So let me go ahead and kind of go to the book real fast to give us some other wording, all right? So if we keep going past the shape, here's a super core concept, and this is the same one that's outlined in the notes that we were just looking at. If we have that symmetric, which means if we cut a line down the middle, what's on the left would be approximately what's on the right. If we have that symmetry, then the mean, that's an old word from section 11.1, the mean, or remember the arithmetic average, the mean is really good for describing the center. And the variation, like how the data differs, that can be used or can be described by, I should say, the standard deviation. So if you have a symmetric histogram or a symmetric collection of data, then the mean is great for being the center. The standard deviation is great for showing the variation. And both of these things technically came from section 11.1. So the easy type of graph, the symmetric graph, goes with the easier, maybe I shouldn't say easy. If you guys remember, standard deviation took a lot of work. But still, the basic way of measuring a center, the basic way of measuring the variation. So section 11.1 is great for symmetric data. But then we have to get to the skewed data. I'm going to get a different highlighter just to make it stand out. So what if we had skewed data? If we had skewed data, that means, well, we can't really draw that center line. It's either going to be skewed left or it's going to be skewed right. But if we have skewed data, then we don't want to use the mean for the center. Instead, we want to use the median. And we don't want to use the standard deviation for the variation. We want to instead use the 5-number summary. Wait, 5-number summary, that's the box and whisker plot from section 11.2. So now we kind of have, in some weird ways, all of our sections all coming together in this one. So we have section 11.1 is really good for the symmetric, but then we have for all the skewed guys, section 11.2 is better for measuring, well, okay, hold on. So the core concepts, what are we talking about when they say choosing appropriate measure? Have you guys caught it yet? We're talking about both what to use for the center and what to use to show the variation. So whenever we're talking about appropriate measures, we're talking about the center and the variation. And we just need to look at the picture and say, okay, is it going to be that symmetric type? If it's symmetric, sweet, let's use the mean, let's use the standard deviation, we're done. Or instead, is it going to be that skewed type, right? Skewed to the left, kicking left, skewed to the right, kicking right. If it's skewed, then we're going to be using that median and that 5-number summary to be our center and to be our variation. Okay, really guys, those are the big ideas of section 11.2a. I just want us to go do an example, see what kinds of questions might be asked of us, and see if you have the main idea down. And remember, once again, the main idea, the vocab words, what to be calling these different displays of data that we're working with. Histograms are those bar graphs, all of them using the idea or having the idea or showing the idea of frequency. That's the histogram. And then the frequency table, okay, well, it's a table of frequencies. I mean, all right. But another way of saying it is it's a way of showing data and showing how often particular ranges occur, how often, how many times. something's going to happen. Let's get to an example that actually has some data, and that might help us out just a little bit. So here we have a table that shows the average annual snowfall in inches of 26 cities. Now, they actually want us to start off by making a histogram. If you guys notice, they've actually just given us a table and not even a frequency table, in that I just see lots of different numbers and maybe they happen more than once. In particular, well, you know what? Let's go ahead and actually follow the directions first of all, before we go looking at this table and trying to get stuff out of the table, okay? So in the very beginning, the very first part says to display a histogram beginning with 15 to 28. Oh, it says 6 intervals, 15 to 28. Well, I mean, when we were looking at all the ones up above, okay, we had like a Y, we had like an X, we had a vertical and a horizontal. If it's a histogram, well, then I know that this has to be frequency, just because that's how histograms always work. And if that's frequency, well, what is it that we're actually measuring? Aren't we actually measuring the average annual snowfall in inches? The average annual snowfall in inches. So this is going to be right down here. We can put average snowfall. If you want, you can put the units. That's never a bad idea, in inches. Okay. They tell us to start off with 15 to 28. So 15 to 28, well, that's going to be this guy right here. And we say, okay, you are an entire range, 15 to 28. All of the different 15 to 28s are going to go right here. Now, with our 15 to 28, we can go look at one of these finished histograms if you guys want. Let me undo that so we can scroll just a little bit. There we go. So do you notice how on a finished histogram, it's not so much that, let me get my little laser pointer out. It's not so much that we're labeling little tick marks like we used to on graphs. We're more just measuring or labeling what's about to be a bar and become a new bar in our bar graph. So let's go ahead and try to make our example not look quite so mathy or quite so algebraic. Let's just go ahead and do kind of what the book did. And what the book did to organize this was to go ahead and say, okay, I have 15, and I hit the eraser for some reason, 15 to 28. Kind of have it off to the side, and we're going to have a bar that we're going to put there in just a second. Now, if we need to have 6 intervals, we need to display the data in a histogram using, using 6 intervals. I see the distance between 15 and 28 is 5 and 8 is 13, right? So if we were to continue that pattern, wouldn't the next data be 29, 2, because I'm just going to the next number. And then I need to go ahead and add 13 to that. So when I add 13, I get 39, and 39 plus 2 is 42. I could go to the next range to get 43, right? That's a messy 3 though, sorry. 43, and I could add 13 to that, and that would be 56. I could keep going. The next guy could be 57, 2. I think I might need to get rid of my label. He's kind of in the way. Okay, adding 13 to that, I believe we would get 67, 70. Then we would get 71. Adding 13 to that would be 84. And then we have 85. Adding 13 to that would be 98. Let's see, how many do we have? 1, 2, 3. Let's count them. 1, 2, 3, 4, 5, 6. Okay, we have all 6 of our ranges. And we just kind of used what they told us right up here in the example. That was a huge help as far as knowing where to start. But then we just went ahead and kept on counting off, going to the next number and adding 13, next number, adding 13 to follow the pattern pretty much. And so now we have to, wait a minute, 15 to 28, isn't that 15 to 28 inches? If that's 15 to 28 inches, isn't this table where they're giving us all of the inches? So in order to make your histogram, you're going to have to look at this table and say, uh-oh, well, unless they tell me like a frequency table of how often something occurs, I need to go find it myself. So if I'm doing the 15 to 28, let me try to color code. Let's go through and find all the ones 15 to 28. There's one, there's one, there's one, there's one. There's one, 15 to 28, 15 to 28, 15. We got quite a few in there. So count those up. And how many did we get? We got, let's see, 1 and 2 and 3 and 4, 5, 6, 7, 8, 9, 10. Double check me. 2, 4, 6, 8, 10. I got 10. And so I'm going to go ahead and come over here now. Some of this is skill, but some of it is, well, 10. I don't know. I mean, it seems like that used up an awful lot of the data. Let's go ahead and put 10 up here. Oh, wait a minute. We're not trying to do the whole crazy math thing. We'll do 10 right here. And then we just want this guy to go up to that height of 10. Up to that height of 10. So how many different, what are we talking about? How many different years, or how many different cities, maybe I should say? How many different cities are going to have between 15 and 28 inches of snowfall? 10 of them. And you can see that 10 right here in our histogram. But now we have to go keep collecting. And the next category is going to be, let's do a new color, 29 to 42. So 29 to 42. Well, okay, that is 29. That counts. To 42, well, 37's in there. So is 30. So is 41, not 43. Where was I at? 29 to 42. Uh-oh, I have some trouble, because did any of you guys just notice? Now, I can go ahead and say yes, 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 all the 30s, you're good. You belong in the one I'm about to do. But does anybody realize where I got stuck? I got stuck right here because 28 is too small for 29. 28 should have been included in the last one. Ah, bummer. I was technically a little bit wrong. It shouldn't have been 10. Instead, it should have been 11. We missed one when we were going through. So let's go ahead and get that 11 up there. But 29 to 42, hold on, let's count up those ones. We just found them. So we have 1, we have 2, 3, 4, 5, 6, 7, 8. I'm going to do one last breeze through, making sure we didn't miss anything. Going to 42. 1, 2, 3, 4, 6, 8. Nope, we're good. So in this one, we're going to go ahead and put 8 instead. And so if we're putting 8, we can just come up here. We're going to go a little bit shorter than 11. If you want, you could actually put tick marks off to the side and make it super precise. I'm just going to go ahead and say, hey, that looks like 8 to me. But if we were to keep going, now we would need to look at 43 to 56. As we look at 43 to 56, oh, now I need yet another color. 43 to 56, well, 44 fits. 43 to 56. 43 to 50. Oh, that got a lot of them that time. 1, 2, 3, 4, 5. I think I have 5 different ones this time. That's going to be roughly half of 11, a little bit under. And I could go ahead and be like, ha-ha. There I am. And here he is. And then what else do we have? That was our green one, our 43 to 56. We need another color in order to do our next one, 57 to 70. I'll get purple out. 57 to 70. I think I just see one. So that one's going to be like a super, 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 super baby one, because he only has one, and that's barely at that. And now I need to go ahead and finish this off. And to finish this off, I have one more category. The one more category, well, actually, we'll have to see. 71 to 84. 71 to, we only have 95. Well, forget it. There's none of those. So we have to go find yet another color. Oh my goodness, I'm running out all over the place. But another color, 85 to 98, and there we have our 95. Perfect. So that's just going to be 1 also. He's kind of boring, but he does go up a little bit because there is 1 of him. At this point, kiddos, you have now made officially your first histogram, at least in this class. And I'm not going to necessarily require you to totally have mastered some of the things in this chapter, in the sense of like the standard deviation, the big old table to fill out, or this idea of making a histogram, but it is like a general idea that you are going to want. And there is the possibility that I might give a question on like a quiz or a test that, since you're allowed to use your notes for. There we go. Coming back and looking at these examples would definitely be helpful. So make sure you're getting this down. But I have my histograms, and we have a couple questions about the histograms once we make them. So let's go ahead and answer these questions, peek at our homework fast, and then we're going to be done. Man, I think my brain's getting tired. So as we look at letter B, this one says which measure and which measure of center and variation best represents the data. If you guys remember just a second ago, we talked about the shape of the data and how the shape of the data really does determine whether or not or what I should use for questions like right down here below where it says, hey, center variation, what's best for that? We have to figure out the shape. And so as you look up above, if you were karate kicking, right? If you were karate kicking, you got to think, which way would your body be leaning? I see the body leaning over here on the left. So which way are you kicking? You would be kicking to the right. That's actually a part of our answer down here, because since there is that skew, I could say since the data is, and not just any skew, but we could say exactly how it's skewed right, because your body would be leaning left and kicking right. Since the data is skewed right, okay, well, for worst comes to worst for right now, you can go ahead and look back and say, oh, I forgot what happens with skewed. Oh, that's all right here. If we have data that's skewed to the right or the left, doesn't matter. Who are we going to use for the center? The median. And who are we going to use for the variation? The 5-number summary. And to be honest, kiddos, it's as easy as answering that. So down here and below, I would say, you know what? I see that it's skewed. And because it's skewed, I'm going to say that the median should be the center, or is the best measurement to use for the center. And the standard deviation is going to be the best way of measuring what we call the variation. Okay? And that's directly out of basically the book or the notes that you've taken up above. You just need to figure out the shape of the histogram. And once we finish graphing it, it was like, oh, easy cheesy, we got it. However, letter C goes on and asks us yet another interpretation question. And so remember, we're talking about the average annual snowfall in inches in 26 cities. And this one starts talking about a weather station listing the top 20 snowiest major cities. Okay, so hold on. What's the question that they're asking us? So they list the top 20 snowiest major cities. The city in 20th place had 51 inches of snow. The city in 20th place had 51 inches of snow. How would you interpret the data? So 20th place, I mean, that's kind of like the lowest one, right? And 51 inches of snow, that's an awful lot of snow. So first of all, if that's the one in 20th place, don't we know from the contest that the other 19 cities are going to have more than, or should have more than 51 inches of snow? That's a little bit crazy, but also we could go ahead and look up here above and say, all right, well, wait a minute, 51 inches of snow, where does that show up here? 51 inches of snow, I believe I see that showing up, well, 51, that's right about here, right? 51 inches of snow, that's right about there. If the weather station lists the top 20 snowiest major cities, the city in 20th place had 51 inches of snow. What does that mean? That means that the other 19 are going to have more than 51 inches, just based on the example itself. And then you could do something else saying like, which is pretty rare. Is it possible up here in your histogram and your bar graph to get over 51 inches? And the answer is yes, of course, definitely. Like there are definitely a few of them that get over 51 inches in this list. But the question is how common? How common? Well, if you guys look at your data, where is most of the data in this set? Remember, karate chop, as you chop or as you kick to the right, the majority of the data is on the other side, is on the left. So most cities are going to get less than 50, even more, less than 70 inches of snowfall, depending on which ones they got and they collected. There are lots of cities in the United States, right? But coming back to this answer, I think I accidentally erased it. The other 19 have more than 51 inches, which is pretty rare. According to our histogram, we know that there aren't that many cities, I should say, they're getting above 51 inches. I'm going to go ahead and go to your guys' book and let's look at your example problems, or let's kind of just peek at your homework problems. The first couple homework problems ask you ideas with vocab and core concept check. We've definitely talked about both of these ideas, both of these key ideas, I should say, in section 11.3a. But then you guys have, I think number 3 is next and number 5 is after that. Number 3 is going to be having you make a histogram. But what's so much easier about this one is when you're making the histogram, display the data in the histogram, describe the shape as skewed right or skewed left or symmetric. This one already did all the hard work for you in that it showed you what the ranges are. You don't have to make them up yourself, thank goodness. And it shows you exactly how many of them fell into those different ranges. And so we could go ahead and be graphing them right away without having to do the crazy color coding and organizing that we did in the one up above. But we also have number 5, a stem and leaf plot. It's a different way of showing data. Not impossible, but when it says describe the shape, symmetric, skewed right, skewed left. What do you guys think if we were to take that data and put it into like a histogram? I wonder what that would look like. It's an odd. I'm gonna let you guys check your answer. Remember, online virtual math lab available every day, Monday through Thursday, which means tomorrow is, yes, a time that you can come check in if you have questions on 11.2 or 11.3. Number 7 is talking about which measure of data is the best. Definitely something that we talked about just a second ago, both in the notes and also in the example that we just did, which also asked us for the best one to use. But then I think you guys also have, I had your homework written down and then I lost the page. It's over here somewhere. Oh, no, I totally lost the page. I'm sorry, guys. Well, I did have that Post-it and now it's gone. But it was 3 and then I think it was 1 through 3, 5, 7, and then I think you guys had 11 also. And as I look at 11, I see it once again talking about the shape of the graph. So the cool thing is with the shape of the graph that you guys already know that one as well. Okay, this video has taken a little bit longer than I anticipated. I'm so sorry, but I hope that that's more than enough information for you guys to go ahead and tackle this one tonight. As far as section 11.3a, 11.3 is not going to be due for a couple days, kind of like the other homeworks have been as well, but you guys will get an 11.3b video tomorrow. That should pop up for you guys to start working on part B homework tomorrow night. And I think I have this, if I were to pull up my calendar real fast, which should be right behind this. Let's see. Oh, here we go. I have section 11.3, and then we have not a puzzle time for this one. Instead, you guys are going to have, here we go, 11.3a, 11.3b. Yeah, 11.3 will not be due until Monday. Then you guys are going to get a review. That's kind of like a quiz, but I'm not grading it necessarily quite as strictly as a quiz. Like you guys will be able to use your notes and your calculators and the example problems and the homework problems. So that should help a little bit. But then we have a review on Monday that's due on Tuesday. It's kind of like a quiz. But yeah, 11.3 guys are going to have the weekend to finish up, but go ahead and try to, after watching this video, start right away and you might be able to bust it out like that. Hope you guys are doing well, and I will be back to help you with 11.3b in just a little bit, so just a little bit tomorrow. And you guys come see me in the Zoom Math Lab. Details are online if you have any questions. Bye, guys.